Hello, this is Philip, and here is a presentation of the EFX Render Elements suite of plugins. Basically, all of these plugins came as solutions to problems I encountered with working with render elements throughout the years. You will recognize two plugins that come free, and you can download them freely from the site, but you'll also have many additional plugins, and I will show them here. So, let's say we have a rendering like this. That's a beauty pass, and we want to recreate it. So we start with a diffuse channel, then add a lighting channel with multiply mode, add shadows, and this is where you encounter the first problem. You've got visible edges between objects because probably because of anti-aliasing algorithms during rendering, the shadows in the shadow pass do not touch exactly the edges of the objects. From what I've seen on the forums, people just deal with it and either leave it like this or render the shadow pass with the lighting pass, so they have one pass less, but avoid this problem. I decided to fix this problem, allowing you to still work with a separate shadow pass, and that's how we do it. So we have the shadow pass, apply the shadow fix, and immediately you can see the edges disappeared. What the plugin does, just expands the shadow layer 1 pixel outside. If you're okay with that, good, you're done. But you might not be okay, because first of all, the shadows here creep into objects, and the shadows here creep outside of the edges. So we basically have to tell the plugin that we want it to work only on edges between two objects. To do this, we have to supply it with two technical passes: a node ID pass that will help it distinguish between a different object, and a Z-depth pass that will help it reduce the effect based on depth information. So the input 2, sorry for not naming these, but Pixel Blender does not allow it. So input 2 is an ID pass, so we select it here. And input 3 is a Z-depth pass. We select it here. So now what happens? You can see that the effect has disappeared. That is because we have a tolerance of Z-depth equal to 0. Basically, two neighboring pixels have to have a difference between their depths, has to be lower than this threshold for the effect to be applied. So if we enlarge this, the effect will start working. And as you can see here on the edge, the effect is working bigger and bigger the bigger the difference between the depth of these pixels is, right? The ID tolerance is for telling it that not to work on the surface of the same object. Now you can see the shadow is here on the floor and it's still expanding. So let's tell it not to work on the surface of the same object with a tolerance of the ID pass. That should be enough. Let's try to remove these with a Z-depth tolerance threshold. Now we can basically see we are fighting two effects. First, the creeping in of the shadow onto the object. We can make it disappear, but then we have an edge here. So I propose we make it disappear like this, and just then play with the opacity of the effect. Let's just reduce it a little bit. If we go to 0, it's like no effect has been applied. 1 is a full effect, and going somewhere in between lets you lower the artifacts and still have a shadow path that looks like it's clean. Okay, then we add a global illumination pass, add, and a funny idea I had. Let's add a reflection pass. Let's enhance it to make it a little bit more visible. Okay. What if you wanted a reflective surface that was, well, a little bit matte? So basically you would have to render a blurred reflection. And that of course takes a while to render. Sometimes you don't have the time, because the differences between a reflection like this and a blurred reflection are like a couple of minutes of rendering to a couple of hours of rendering. So the first idea is, let's blur the path. So let's blur the reflection path. Okay, that's not bad. Apart from one detail, that we're actually blurring the reflection path between separate objects. As you can see, the blurring effects do not respect the boundaries between objects. So the whole effect of blurring the reflection is pretty visible. That's where we come in with EFX RE blur. Basically, it's a blur that distinguishes between different objects. We have to supply it again with a material ID path, and then we can blur the reflection. As you can see, the reflection blurs as before, but the blurring does not cross the borders of an object. Unfortunately, this will result in artifacts on edges of objects. Let me get back to it later, because this is a problem that you will always encounter when you're trying to work with render elements. You have a couple of these blurs, so let's distinguish between them. These three blurs are basically exactly the same. The difference between them is the maximum blur amount allowed. So this filter can blur at maximum of 10 pixel radius, this 20, and this 40 pixel radius. Why I did it this way is, again, because Pixel Blender does not have a built-in blur function. I had to write it from scratch. And apparently the maximum radius of the blur influences the speed at which the plugin operates. Just to show it, if we apply the 10 pixel blur, it thinks a little, but then it's ready to go, right? If we apply the 20 pixel blur, it thinks a little longer, and then it's ready to work. But the 40 pixel blur will unfortunately think a while. It's still thinking, preparing. I have no idea what it's doing actually. It's probably initializing the filter. And as you can see, the difference in time it requires to initialize the filter is enormous, especially on HD footage. That's why basically you've got three different filters, and just use the amount of blur that suits you and nothing higher. Yeah, now it's initialized. So again, and it happens that it has to re-initialize from time to time when you pre-compose a composition or something, and you have to go through the waiting all over again. And once again, if you apply the 10 pixel blur, which is more than enough for many cases, it works straight away. So that's why you have three versions. Next we have a EFX RE ZDev blur, which is basically the same, but you have additionally a second input. The second input waits for a ZDev map. Basically, imagine you have a big reflective object like a torus knot or a character. We had a big blobby snake, and basically it's one mesh, so it's going to have a single ID all over, and this filter will not really work at all on it. It will be acting just like an ordinary blur. So here you can additionally to the ID pass supply a ZDev pass, which will allow you to set a ZDev tolerance for pixels that if they fall below this threshold, they will be blurred together. If the difference in z depth is higher than this threshold, they will be considered an edge of an object, and the blur will not cross over the edge. That's a solution to the situation where you have only one object, but big, intersecting with itself. So other functions we have, this is basically a way to make a blur more blurrier, picking between, I don't know, a Gaussian blur and a box blur or fast blur algorithm. So without changing the radius here, you can change the gamma and have a different shape of the blur fall off. And of course ID tolerance here is helping you just add some pixels that are on the edges, and this is a way to remove some of the artifacts on the edges. Be careful not to go all the way up to 1, because you'll just do a normal blur then, right? It will tolerate all the IDs as one ID, and you will go over the edges with the blur. So let's not go all the way up with this. I promised you we would try to deal with the edge artifacts, and that's what we do now. Let's add an adjustment layer and add a filter that's called edge blur. Again, supply the node ID mat, and what edge blur does, it basically allows you to find edges between objects. You have 3 options: show edges, show soft edges, that's a little bigger and softer of course, and the final. And what it does, it finds the edges, and within these edges it blurs the image. So as you can see right now, we can blur the edges less, more, and remove the artifacts. Still an ID tolerance here, and the mix amount is just the way to back off the effect to 0 or stay with the full effect.